According to the National Electrical Code, all 15 and 20 ampere 125-volt non-locking type receptacles installed in basements and garages must be GFCI protected. This includes duplex receptacles, even if they are not currently being used. The NEC defines a basement as a story of a building that is partly underground and partly above grade, with at least one half of its height below grade. A garage is defined as a building or portion of a building in which one or more motor vehicles are housed, but not repaired. The purpose of this code requirement is to protect people from electrical shock in the event of a ground fault. A ground fault occurs when an electrical current flows through an unintended path, such as through the ground or through a person's body. GFCIs work by comparing the current flowing through the hot and neutral wires. If the current flowing through the neutral wire is significantly less than the current flowing through the hot wire, then a ground fault is likely occurring. The GFCI will then trip and open the circuit, preventing the flow of electricity. In your case, even though some of the duplex receptacles in the basement and garage are not currently being used, they are still required to be GFCI protected. This is because it is possible that they could be used in the future for the plug-in of other electrical devices, such as power tools or appliances. If these devices were to develop a ground fault, the GFCI would trip and protect the person using them from electrical shock. I recommend that you install GFCIs on all of the duplex receptacles in the basement and garage, even if they are not currently being used. This will help to ensure the safety of anyone who uses these receptacles in the future. To further clarify, let's delve deeper into the specific requirements and reasoning behind GFCI protection in these locations. Firstly, understanding the definitions provided by the NEC is crucial. The NEC clearly distinguishes between basements and garages, and it's important to recognize that the GFCI requirements apply to both, regardless of whether the space is finished or unfinished. Secondly, the rationale behind the code is paramount. Electrical safety is not just about preventing immediate hazards but also about anticipating potential risks. Even if a receptacle is not in use currently, the possibility exists for future use, and the code aims to provide a baseline level of protection for any potential user. Thirdly, the mechanism of a GFCI is important to grasp. A GFCI constantly monitors the current balance between the hot and neutral conductors. A slight imbalance, as small as 5 milliamperes, can indicate a ground fault, triggering the GFCI to trip within a fraction of a second. This rapid response is critical in preventing electrocution. Fourthly, the code mandates GFCI protection for all 15 and 20 ampere 125-volt receptacles in these locations. This is not limited to receptacles near sinks or water sources, but includes all receptacles regardless of their proximity to moisture. The intention is to provide comprehensive protection throughout the basement and garage. Fifthly, consider the types of equipment commonly used in basements and garages. Power tools, lawn equipment, and other appliances are often plugged into these receptacles. These devices can pose a higher risk of ground faults due to their construction or usage environment. Sixthly, the NEC is updated regularly to reflect advancements in technology and evolving safety concerns. It is essential to stay informed about the latest code requirements and interpretations to ensure compliance. Seventhly, installation of GFCIs should be performed by qualified personnel. Proper wiring and testing are crucial to ensure the GFCI functions correctly and provides the intended protection. Eighthly, regular testing of GFCIs is recommended to verify their functionality. Test buttons are provided on GFCIs for this purpose and should be used periodically to confirm that the device is working as intended. Ninthly, in some cases, it may be permissible to provide GFCI protection for a group of receptacles using a single GFCI device. However, this approach should be carefully evaluated to ensure that all protected receptacles are adequately covered and that the GFCI device is readily accessible for testing and reset. Tenthly, the requirements for GFCI protection may vary depending on the specific edition of the NEC in effect in a particular jurisdiction. This is important to consult the local electrical code to determine the applicable requirements. Moving on to more specific scenarios, it's important to consider the different types of basements and garages. Some basements may be fully finished and used as living spaces, while others may be unfinished and used for storage or utilities. Similarly, garages may range from detached structures to integral parts of a home. Regardless of the specific characteristics of the basement or garage, the GFCI requirements generally apply. Now let's dive into how a GFCI works in more detail. The device contains a differential transformer that continuously monitors the current flowing in the hot and neutral wires. Under normal conditions, the current flowing in the hot wire should be equal to the current flowing in the neutral wire. However, if a ground fault occurs, some of the current will flow through an unintended path, such as through a person's body or through the ground. This creates an imbalance between the hot and neutral currents. The differential transformer detects this imbalance and signals the GFCI to trip, interrupting the flow of electricity. The GFCI is designed to trip very quickly, typically within 25 milliseconds, to minimize the risk of electric shock. This rapid response time is crucial in preventing serious injury or death. It's also important to understand the difference between a GFCI and a circuit breaker. While both devices provide overcurrent protection, they operate on different principles. A circuit breaker protects against overloads and short circuits by interrupting the flow of electricity when the current exceeds a certain threshold. A GFCI, on the other hand, protects against ground faults by detecting imbalances in the current flowing in the hot and neutral wires. In addition to the NEC requirements, there may be local codes or regulations that further specify the requirements for GFCI protection. It's important to check with the local building department or electrical inspector to ensure compliance with all applicable codes. When installing GFCIs, it's important to follow the manufacturer's instructions carefully. Incorrect wiring can prevent the GFCI from functioning properly or even create a safety hazard. It's also important to use the correct type of GFCI for the application. There are different types of GFCIs designed for different purposes, such as those for use in wet locations or those for use with specific types of equipment. Another important consideration is the location of the GFCI device. It should be installed in a readily accessible location so that it can be easily tested and reset. It should also be protected from physical damage and exposure to moisture. Regular testing of GFCIs is essential to ensure that they are functioning properly. The test button should be pressed monthly to verify that the device trips and interrupts the flow of electricity. If the GFCI fails to trip when the test button is pressed, it should be replaced immediately. It's also important to understand the limitations of GFCIs. While they provide excellent protection against ground faults, they do not protect against overloads or short circuits. They also do not protect against electric shock if a person comes into contact with both the hot and neutral wires simultaneously. In summary, GFCI protection is a critical safety measure that helps to prevent electric shock in basements and garages. By understanding the NEC requirements, the principles of operation of GFCIs, and the proper installation and testing procedures, you can ensure that these spaces are safe for yourself and others. Furthermore, let's address some common misconceptions about GFCI protection. Some people believe that GFCI protection is only necessary in areas where there is water present. While it is true that GFCI protection is particularly important in wet locations such as bathrooms and kitchens, it is also required in basements and garages regardless of the presence of water. The reason for this is that basements and garages are often used for activities that can increase the risk of electric shock, such as using power tools or working on vehicles. Another misconception is that GFCI protection is only necessary for receptacles that are being used. As we have already discussed, the NEC requires GFCI protection for all 15 and 20 ampere, 125 volt receptacles in basements and garages, even if they are not currently being used. This is because it is possible that they could be used in the future, and the code aims to provide a baseline level of protection for any potential user. Some people also believe that GFCI protection is not necessary if the wiring in the basement or garage is new or in good condition. While it is true that properly installed and maintained wiring can reduce the risk of ground faults, it does not eliminate the risk entirely. Ground faults can occur for a variety of reasons, such as damaged insulation, loose connections, or faulty equipment. GFCI protection provides an additional layer of safety that can help to prevent electric shock in the event of a ground fault. It's also important to note that GFCI protection is not a substitute for proper grounding. Grounding provides a path for fault current to flow back to the source, which can help to trip a circuit breaker or fuse and prevent a dangerous voltage from building up on metal objects. GFCI protection and grounding work together to provide comprehensive electrical safety. In addition to receptacles, GFCI protection is also required for certain other types of electrical equipment in basements and garages, such as lighting fixtures and appliances. The specific requirements vary depending on the type of equipment and the location. It's important to consult the NEC or a qualified electrician to determine the applicable requirements for your specific situation. Finally, let's consider the cost of GFCI protection. While GFCIs can be more expensive than standard receptacles or circuit breakers, the cost is relatively small compared to the potential consequences of electric shock. GFCI protection is a worthwhile investment that can help to protect you and your family from serious injury or death. To recap, GFCI protection is a critical safety measure that is required by the NEC for all 15 and 20 ampere, 125 volt receptacles in basements and garages. It protects against ground faults, which can cause electric shock. GFCI protection is not limited to wet locations or receptacles that are currently being used. It is a worthwhile investment that can help to protect you and your family from serious injury or death. When it comes to electrical safety, there is no substitute for knowledge and caution. By understanding the NEC requirements, the principles of operation of GFCIs, and the proper installation and testing procedures, you can ensure that your basement and garage are safe for yourself and others.